Here we have AP calculus AB problem. Okay, let's go to the information. Find the absolute maximum and absolute minimum values of f on the interval 0, 3. So the function f of x equals to x cubed negative 4x squared positive 7x over x. Okay, so first let's understand the concept on how to find the absolute maximum and absolute minimum value of a function. Okay, now let me consider a function f of x on the closed interval a, b. Okay, so to get the absolute maximum and absolute minimum values of this function f of x on the closed interval a, b, so what I have to do is first I have to find the critical numbers of the function f of x. So I'll explain you later how to find critical numbers of a function f of x. So for example, I am getting two critical numbers for this function f of x, say c and d. Okay, now what I have to do is I have to evaluate the value of the function at the critical number c and d. That is, I have to plug in this c and d for x over here. So then I'm getting f of c and f of d, and also I have to evaluate the value of this function on the boundary values of the given interval. That is a and b. So then I'm getting f of a and f of b. So now I just got four values for the given function f of x. Two values I got it from the critical numbers, and two values I got it from the boundary values of the given closed interval. So among these four values of the given function, the one which is minimum is called absolute minimum. The one which is maximum is called absolute maximum. Okay, now our first work is to find the critical numbers. So how do you have to find the critical numbers? So for that, what we have to do is we have to find the first derivative of this of the given function. So before we find derivative, if there is any possible simplification over here in the expression on the right side, first we have to do that. So once we are done with the simplification, we can start finding the first derivative. Okay, so here x is a common denominator for the three terms we have in the numerator. When you look at the terms in the numerator, all the terms contain variable x. So since it's a common denominator, this x can be taken as a denominator separately for each term, so that I can simplify the given function. Let me do it. So f of x equals to, now I'm going to take this x as denominator separately for each of the terms in numerator. Then I'm getting x to the third power over x, negative 4x to the second power over x, positive 7x over x. So this x will cancel out. So I'm getting f of x equals to, when I divide x to the third power by x, I'm getting x square. Negative, when I divide x square by x, I'm just getting x, that is negative 4x, positive 7. Okay, now to get the critical number, I have to get the first derivative of the given function. So let me get the first derivative, that is f prime of x equals to, so I can get the derivative of this x square using the power of derivative. When I do so, I'm getting 2x. Negative, the constant over here is multiplied by the variable x. When I find derivative, if there is a constant multiplied by the variable, I have to keep the constant as it is, and I have to find the derivative of the variable alone. When I find the derivative of this variable x with respect to x, it will become 1. So the derivative of this constant 7 is 0. So then I'm getting f prime of x equals to 2x negative 4. Okay, now I got the first derivative. Now what I have to do is I have to equate this first derivative to 0 and solve for x. So f prime of x has to be equated to 0. Then I'm getting 2x negative 4 equals to 0. Now let me solve for x in this equation. So this negative 4 positive will cancel. I'm getting 2x equals to positive 4. Then I divide by both sides by 2. Then 2 will cancel. I'm getting x equals to 2. Okay, when I equate the first derivative to 0, I'm getting x equals to 2. So this is one of the critical numbers for this function f of x. Okay, whenever I want to find critical numbers, so usually the stuff what I've done so far has to be done. That is, I have to find the first derivative, equate it to 0 and solve for x. And also, I have to check whether there is any value of x for which this f prime of x becomes undefined. In case there is any value of x for which the first derivative becomes undefined, so that value of x also should be considered as critical number, and also that value of x should be in the given domain. So here I got a critical number 2, but now I'm just checking whether there is any value of x for which f prime of x becomes undefined. But here it's a polynomial, so 2x 94 is defined for all real values of x. There is no value of x for which f prime of x becomes undefined. In case there is any value of x for which this f prime of x becomes undefined. So just for an example, I'm saying f prime of x equals to, let's consider 2x negative 4 over x minus 1, something like this. So is there any value of x for which this f prime of x becomes undefined? Yes, when x equals to 1, the denominator becomes 0, then f prime of x becomes undefined. So x equals to 1, we have to check whether there is we have this value in the given domain. If you have this value in the given domain, so this 1 also should be considered as a critical number. But in our problem, so here for f prime of x, we just have 2x negative 4. This is defined for all real values of x. There is no value of x for which f prime of x becomes undefined. So for this function, there is only one critical number, that is x equals to 2. Okay, now what I have to do is I have to consider the given interval. The given interval is not completely closed. On the right side it is closed because we have a square bracket, but on the left side it is not closed, it's open because we have parenthesis over here. So parenthesis means what? What is meant by parenthesis? Means open interval. Open interval means the boundary value over here. So on the left hand, 0 should not be included. But when you have square bracket, it's closed. That means the right side boundary value can be included. So x can take any value greater than 0, not 0, greater than 0, up to 3. Even 3 also can be considered for x. So as I explained the stuff like we have to find the value of the function f of x at the critical number, the boundary values, but when it is closed, completely closed on the left side also, if it is closed, we can check, we can evaluate the value of this function at x equals to 0, but its left side is not closed, it's open, so we cannot include 0. So from the given interval, we can consider only one boundary value, that is the right boundary value 3. And also we have to evaluate the value of the function at the critical number 2. Okay, now let me evaluate the value of the function at x equals to 2. Then I'm getting 2 to the third power negative 4 times 2 square positive 7 times 2 over 2. So then f of 2 equals to, the evaluation of this 2 cube is 8 negative, the evaluation of 2 square is 4. 4 times negative 4 is negative 16 positive 14 over 2. So then we get when I combine this negative 16 and positive 14, I'm getting negative 2. 8 negative 2 is 6 6 over 2, which is equal to 3. So when I evaluate the value of the given function at the critical number 2, I'm getting 3. Okay, now let's evaluate the value of the given function at the right side boundary value of the given interval. We cannot consider the left side, already explained it. So because it's an open interval, 0 is not included. Now let me evaluate the value of the given function at x equals to 3. Then I'm getting 3 to the third power negative 4 times 3 square positive 7 times 3 over 3. So the 3 cube is equal to 27. Let me write f of 3 on the left side. Negative 3 square is 9, 4 times 9 is 36, and 7 times 3 is positive 21 over 3. Okay, when I combine negative 36 and positive 21, I'm getting negative 15. When I combine negative 15 and positive 27, I'm getting positive 12 over 3. So when I divide 12 by 3, I'm getting 4. Okay, so here I got two values for the given function. So one is f of 2 equals to 3. And other one is f of 3 equals to 4. In these two values, the one which is minimum is absolute minimum, and the one which is maximum is absolute maximum. So absolute minimum is 3 that we have at x equals to 2, and the absolute maximum is 4 that we have at x equals to 3.